All right, welcome. Today, we are diving into one of the most important topics in cloud architecture, and that's resilience. We're going to break down how to design systems on Azure that aren't just built to survive failures, they're built to expect them. Let's dive in.
But before we get into any of the tech, let's just stop for a second and start with the most critical question of all. What would 1 hour of downtime actually cost your business? Is it $1,000, $100,000, maybe millions? Seriously, the answer to this question is the engine that drives every single architectural decision we're about to talk about. Because resilience, it isn't just a tech feature, it's a core business strategy.
So here's our game plan for today. We're going to start with a really crucial mindset shift. Then we'll define the 2 metrics you absolutely have to know. After that, we'll compare the main strategies, see how it all works on Azure, and then wrap up with the 3 essential questions you need to be asking for any project you work on.
Okay, Section 1. This gets right to the heart of modern cloud design. It's about a complete shift in our thinking. See, it's no longer about trying to prevent failure, because you can't. It's all about designing a system that can gracefully handle it when it, inevitably, happens.
And this right here is the golden rule. You just can't treat resilience like some feature you bolt on at the end of a project. It has to be woven into the very fabric of your application right from day one. The best architectures are resilient by design, not by accident.
So, if we're designing for failure, how do we actually define what success looks like? Well, we need a common language, and that language is built on 2 simple, non-negotiable metrics that bridge the gap between what's technically possible and what the business actually needs. First up, we've got RPO, the Recovery Point Objective. Just ask yourself this: if the whole system went down right this second, how much data would be acceptable to lose forever? The last 15 seconds of orders? The last hour of user activity? This number, your RPO, directly tells you how frequently you need to be backing up or replicating your data. And just remember, a tiny RPO, like a few seconds, is way more complex and expensive than, say, a 24-hour RPO.
And then you have its partner, RTO, or Recovery Time Objective. This one is purely about the clock. When a disaster strikes, what's the deadline to get everything back online and serving users? An hour? 10 minutes? A few seconds? Your RTO is what determines the kind of automation and recovery plan you're going to need.
All right, so now that we have our RPO and RTO defined, we can start looking at the 2 main strategies for actually hitting those targets: high availability and disaster recovery. They might sound similar, but they protect you from very, very different kinds of problems. This analogy honestly makes it so clear. Think of high availability, or HA, as a multi-engine plane. If one engine fails mid-flight, the other engines just take over automatically, and the plane keeps on flying. You probably don't even notice. It's all about handling those small local failures, like a server or a network switch failing inside a single Azure region. Now, disaster recovery, or DR, that's your backup plane waiting at a completely different airport. If your first plane can't take off because a hurricane flooded the entire airport, you trigger your DR plan to get that second plane in the air. It's for protecting against massive regional-level outages.
Okay, enough theory, right? Let's see how this all plays out in the real world. We're going to take a super simple web application and we're going to build it up layer by layer from being fragile to being fully resilient, using actual Azure concepts.
So, we start at step 1, a single web server. This is a classic single point of failure. If it goes down, your app is down. Simple as that. So, for step 2, we introduce high availability. We do this by deploying our app across multiple availability zones within one Azure region. Think of these as physically separate data centers with their own power and cooling. Now, if one zone goes down, a service like Azure Load Balancer just automatically sends traffic to the healthy instances in the other zones. But what if the entire region has a problem? Well, that brings us to step 3, disaster recovery. Here, we can use a service like Azure Site Recovery to replicate our whole setup to a second paired Azure region. Then, we'd have something like Azure Traffic Manager sitting in front, ready to redirect all our users to that second region if we ever need to fail over.
But that disaster recovery step, it's not a one-size-fits-all deal. It's really a spectrum, a trade-off between speed and cost. A hot strategy, where your backup environment is literally running and ready to go at a moment's notice, gives you an incredibly fast recovery time, but it costs a lot. On the other end, you have a cold strategy, super cheap, but your recovery could take hours, maybe even days. It's your business's RTO and RPO that tell you exactly where you need to be on this chart.
Okay, we have covered a ton of ground. The mindset, the metrics, the methods. And that brings us to what might be the most crucial takeaway of this whole thing.
Before you design anything, before you write a single line of code, you absolutely have to get the answers to these 3 questions. And here they are. First, what are the RTO and RPO? And notice that key phrase, business defined. This can't be a guess from the tech team. Second, what's the budget? Because near-perfect resilience is possible, but it has a cost, and you have to understand what trade-offs are acceptable. And third, and oh man, this is the one people always forget. How much complexity can your team realistically handle? An amazing automated failover is useless if your team doesn't know how to confidently fail back once the crisis is over.
So let's just wrap up with a certainty. Your components will fail. Your networks will go down. Data centers will have problems. That is a guarantee. The only real question, the only one that matters is this: is your architecture ready for it?